Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the ACT. We have been solving ACT math problems out of this book here, the official ACT prep guide. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 171. Please turn to it, page number 171, and today is our lesson number 9. Let's take a look at it. Very first problem there. We are given a little chart there and we are being asked, number 29, we are being asked what fraction of the cars were assembled in Coopville. Now if you look at the chart carefully, the car town we are shown 4 symbols there. The next one, Coopville, is 2.5, and then we have Truck City, which is 2, and let's put them here. Car town we are shown 4, Coopville we are shown as 2.5, Truck City is 2, and so finally Sedan Falls, which is the last one, we are shown as 1.5. Let's add them up, shall we? So we get half and a half, that's a 1, so we carry 1, and there we get 1 plus 4 is 5, and then 2 plus 2 is 4, plus 1 is 5, so 5 plus 5 is 10. So its total is 10. It's very straightforward. So question is, what fractions were assembled in Coopville? Well, that's Coopville over the total. Coopville is 2.5 right here. It's 2.5 over 10. 2.5 over 10. 2.5 is what fraction of 10? 2.5 times 2 is 5, and 5 times 2 is 10. So this is 1/4. That's solved. One out of every car out of these 10,000 cars was assembled in Coopville. The answer is 1/4. The answer is B. Let's go to the next one, number 30. Number 30. In number 30, we are told that point B and C lie on line AD. Alright, so here's our AD. How long is AD? They go on to tell us that AD is 30 units long. And they say that A to C is 16. So somewhere here is the halfway, so A to C, let's put it here, A to C, we are told is 16. This here, I'm showing approximate halfway mark, you understand? What else do they show us? B to D, they tell us is 20. B to D. B to D is 20. What exactly are they asking for? How many units long is B to C? Well, B to C is from here to here, right here, from here to here. This is your B to C. This is the portion that is B to C. But this all the way from here to here is 20, and from here to here is 20 is 16. Okay, listen carefully. This is 20. Let's put it here. A to C. A to C, we are told is 16. Plus B to D is 20, we are told, but that's 16 plus 20 is 36. 16 plus 20 is 36, but the entire length from A to D is only 30, which means this overlapping part must be 6 units. The overlapping part is 6 units long. overlapping portion, which is what they're calling B to C, is 6 units. It's 6 units long. It's 6 units long because if you add up individually, A to C is 16, B to D we are told is 20, 16 plus 20 is 36, but the entire length from A to D we are told is only 30 units long. So 6 units is what we are counting. We are double counting. That's the overlapping part. Number 31. Number 31. Just give me 1 second break again. Number 31. What is the x coordinate of the point in the standard xy coordinate system at which two lines, so what's the x coordinate? What is the x coordinate of the point where lines y equals to 2x plus 6 and y equals to 3x plus 4 intersect? Well, let's find out, shall we? Let me show you in picture as to what it looks like. We're done with this part. We need the room, obviously. I'm going to erase it now. So here is our xy plane. Okay, I'm just going to draw it freehand. You understand what freehand means? I'm just going to draw it freehand. In other words, the lines that I'm going to draw are not going to necessarily look like the way they actually are, but it doesn't matter. So here's our one line, here's our other line, and there are two lines that are intersecting. This is the point of intersection. At that point of intersection, they have the same y coordinate and same x coordinate, of course, because that's why it's called the point of intersection. So the y coordinate of this point is same for the line, the first line and the second line. So that's what we're going to do. The y coordinates are the same. So we're going to equate this quantity. We're going to equate this quantity to this quantity. 2x plus 6 would have to be 3x plus 4, because whatever the y coordinate is, which is y equals this quantity, 2x plus 6, and in the second line we are told y equals 3x plus 4. And at the point of intersection, they have the same x coordinate and the same y coordinate. So the y value of this point has to be the same for both of them. So we equate the two and we find out the x. That's all. So we have to bring all the x's on one side and all the known quantity on the other side. Typically we would have brought the 3x to the left hand side. Listen carefully. But if we bring 3x to the left hand side, we'll end up with a negative coefficient with the x. I don't want that. Let's bring 2x on the other side. So this is positive 3x. Let's subtract 2x from both sides. And let's bring 4 for this side. That's it. So here we have positive 2x and a negative 2x. They're going to cancel out. Here we have positive 4 and negative 4. They're going to cancel out. So we are left with positive 6 and a negative 4. Positive 6 and a negative 4 is 2. And 3x minus 2x is x. There you go. X equals 2. The x coordinate is 2. Finding the y coordinate is not that difficult. We can do it in 2 seconds, even though they are not asking for it. But y coordinate, we can substitute this value of x. We can substitute this value of x in either of this equation. If you put it in the first one, x is equal to 2. 2 times 2 is 4. 4 plus 6 is 10. Had we substituted the value of x coordinate in the second one, we would have gotten the same answer. 3 times 2 is 6, and 6 plus 4 is 10. You see? There is your point of intersection. That's all. If we call this thing, let's call this thing L1 and L2. Okay, now I'm doing extra work, which is not being asked in the problem. We're just doing extra work. This is our L1, the first line here, where when x is equal to 0, y is 6. So this start part here, this is our L1. And when x is equal to 0 in the second one, y is 4. Y is 4. This is our second line, L2. This is L2. And this is 4 and this is 6. That's all. And this is, we just found out, this is 10. This point is 10. But as I said, it is drawn freehand, so obviously it's not drawn to scale. I'll see you tomorrow, okay? Bye now.